Hey, you guys, it's Josie with Queen White Pawn, and I'm going to be showing you an argument where 1 equals 2. Take a look at this. What is wrong with the following proof that 1 equals 2? Try to figure it out for yourself by going through each of the steps. They start off by saying let x equals y, which just means let two numbers equal each other, call them x and y, or box 1 and box 2. Then follow those steps. Pause the video. I'm going to give you a hint after 3 seconds for you trying to pause the video, and then I'll ask you to pause the video again. So pause the video now, and 3 seconds later, I'll give you a hint if you still can't figure it out. Now here's a hint. All the algebra here is right, but one of the properties of the numbers, which include the associative, commutative, distributive properties, and the inverse properties and the identity properties, one of those was used wrong. Can you find out where? So another 3 seconds to pause the video and try to figure it out for yourself before I go on and show where it is. Okay, so they make a compelling argument. They say that 2 equals 1. Algebra was right, but they forgot about the property over here about inverses. They said x plus y times x minus y equals y times x minus y. I just read this basically. And then they canceled out whatever was same. You know, it's like if you have 5 times 3 equals 5 times 3. You could cancel out the 3 and the 3, and you get 5 equals 5. Basically, that's all they did. So what they basically did here is, in other words, they divided by, or they multiply by the inverse of 3, which is 1 over 3. Remember, every number has an inverse. And when you multiply that number by its inverse, you should get 1. So can you find out exactly where this would go wrong? Well, let's try multiplying by the inverse. X minus y, negative 1. Now, these two should cancel out, right? But remember, x is equal to y. So if x is equal to y, then that means that x minus, or x equals y leads to subtracting x from both sides. Or actually, let's subtract y from both sides. I think that's easier to prove. And then, x minus y, these two cancel out. That's the additive inverse. And you get 0. So that means that we can plug in 0 here. Okay. Then the problem basically boils down to this. 0 multiplied by its inverse, whatever that may be, that'll give you 1. But that's impossible. You can't multiply anything by 0 to give you 1. 0 doesn't have an inverse. You multiply 0 by anything, and it should actually give you 0. That's the thing. You learn later on in functions that when a lot of things map to one number, that number tries to go backwards and it goes to many different numbers. It's impossible to determine which one it'll go to, and mathematically that's not satisfactory. You can't have one train take you to 2 stops at the very same time. And I cover that actually in my video about functions. So that's where they messed up in this step. And 2 does not equal 1 then. This proof is incorrect. So I hope you enjoyed the video. Make sure to give it a like, subscribe for more content, and I'll see you in the next one.